I guess, as mentioned, right, today's session is going to be, security question, topic rather. Before we talk about that, I want to talk a bit about AWS Reinforce. Maybe before I get into that, a question to the floor. Does anybody know what AWS Reinforce is? It's a platform where AWS has created together with our partners, where all the security heads from around the world can come together and learn more about AWS security from our partners as well as AWS security experts. So we collaborate with security partners who are leaders in that space, such as CyberArk, Ping Identity, and CrowdStrike, to name a few. Together with our partners, as mentioned, we just create a platform where our customers can come and learn about how to build secure applications on AWS. And this year's Reinforce was hosted in Anaheim, in California. So we had over 6,000 registrations and over 200 breakout sessions and workshops. So these workshops and sessions were spread across different topics or tracks. So we had the identity track, network security, application security, infrastructure security, as well as compliance. So each track had a bunch of sessions and workshops. So for those of you who are only finding out about Reinforce, today, if you are interested, I am going to share the slides with you after the session. In the slides, there's links that you can go to and learn a bit more about Reinforce. We also have on-demand videos of the sessions and the workshops that were held at this year's Reinforce. So if you're keen to learn about some of the service announcements, but as well as some of the cool solutions that both AWS experts and our partners have been building, you can just have a look at those on-demand videos. All right, as mentioned, today's topic is going to be on Zero Trust, specifically how to go on about building Zero Trust architectures on AWS. Before we get into it, just a few housekeeping rules on my side. If there are any questions from the floor while I'm presenting, please feel free to stop me and ask me. You can ask the questions on the chat. I will try to look at it as I'm presenting, but if I don't see your question, Enoch, I ask that you please have a look there, and if there are any questions coming through, please just let me know.
Sure.
And I think today I really just want to have a very comfortable space for everybody to ask questions, and would like to be to have this as a conversation more than me just talking to you. So if you've got any questions, if you've got any interesting comments, really I'm looking forward to hearing from you. Please stop me and let's have a conversation around security. And one other thing, if you feel that I'm speaking too fast again, right, just let me know, and I'll try to slow things down a bit. All right, so this is the agenda for today. So we are going to have a look at what Zero Trust is all about, and have a look at some of the guiding principles, right? As you're starting to think about building your applications that follow Zero Trust, we're going to have a look at some of the principles that you can look at that can guide you on that journey. And then we are going to explore the AWS mental model for Zero Trust. This is basically how we conceptualize and approach Zero Trust from an AWS perspective. This will help us, gain a better understanding of the principles behind Zero Trust. And to illustrate these concepts, we're going to delve into some of the specific examples of how AWS implements Zero Trust in practice. We will then close off the session by having a look at how our customers, right, can build applications following this model. So we'll have a look at some of the AWS services that can be used to achieve zero trust on AWS. All right, so what exactly is zero trust? So, as mentioned, I would like for us to have a conversation right around this topic. So I'm going to open up the floor. Anybody who wants to, just share with us what their understanding of zero trust is, except for Enoch. Anybody? Andre, how about you? Wanna try? Oh, Kenny, I see that you want to say something.
Yeah, I feel like zero trust actually is like some kind of security model, right? Yeah, like I don't really know much about it, but yeah, I feel like it's like some kind of security model for AWS. Yeah.
Okay, cool. That's spot on, right? It's a security model, right? And security models basically help organizations, right, to in their thinking, right, in architecting and building their digital assets, right, on how to protect them, right? So it's definitely a security model. So yeah, thanks there, Kenny. We will get into it a little deeper and understand what that model is all about. But before we move on, I want to see if there's anybody else who wants to add something to what Kenny has already said.
Okay, I could try say one or two things. I think AWS zero trust is a situation whereby in an organization you do not trust or you give only the privileges that are very, very necessary to each individual in the organization.
Absolutely, right. And I think what you wanted to say that you do not trust anyone, right? And essentially that's what it is. Right?
Essentially necessary to give that person the privilege. You do not, even if the person is in the organization.
Yeah, exactly, right. And that's pretty much it, right? It's that model, right? Where you follow the least privilege, framework, right? You do not grant access to resources of anybody who doesn't necessarily need those privileges. So yeah, so let's have a look at how at AWS we think of zero trust, right? So at AWS we work backwards from our customers, right? We talk a lot with our customers, and most of the stuff that we do is stuff that is actually influenced by what our customers say, right? And when we talk to our customers, most of the things that we pick up from there, right, especially in the security area, right, is customers are constantly asking themselves questions, right? And those questions usually lead to them having a look at models such as zero trust, right? And the number one thing for customers when it comes to security is the number one question is, have I done enough, right, to protect my digital assets, right? And that question leads us into frameworks such as zero trust. So the actual definition, right, of zero trust is it's a security model, right, that focuses on helping you implement security controls for your resources. So traditionally, security controls have always been, network-centric, but zero trust, though it focuses on network security controls, with zero trust, we want to look at more controls. We want to look at, more than just network controls. So it's not just about building a network perimeter for protecting your resources, but it's looking at what other options are there to help you improve your security. We want to look for those controls, right, that can help you answer the question, if you have done enough as a customer to protect your digital assets. So the best way, right, to explain what zero trust is all about, right, is by having a look at a real life example, right? And what you see on the screen there is an image of a museum, and let's think about the concept of a museum. So we know that in the museum you find the most expensive art And the main idea of a museum is to let people enjoy that art, right? We don't want to look it away, but we want to allow people to walk in and see that art. Now, a museum is a building. It has walls, windows, and doors. So these serve as security controls, right? And in addition to that, if you go inside a museum, you have to first go through security checks or clearance. And once you've been cleared, you can go inside and you can then enjoy the art. But the security controls don't stop there. Inside the museum, there's ropes and there's glass protecting the art. You also have security personnel inside. There's also surveillance controls as well as alarm systems. So if you get too close to the art, either an alarm will be triggered or the security personnel will come and they will deal with you. So going back to the main aim or the goal of a museum is to let people enjoy art. However, we want to make sure that the art is protected. So instead of implementing just one security control, we implement a few controls to make sure that we have done enough to protect the expensive art. So that is, at this point in time, right, probably one of the best examples, right, of, of a real life, zero trust, principles in real life. Now, we're going to have a look at how, from an AWS perspective, right, that can be achieved, going back to what, Coyote said about making sure that you're allowing only the necessary personnel to access the specific resources, right? We're going to have a look at those in the next coming slides. But essentially, the idea is that you not only look at just one control, right? You have a bunch of controls that are aware of each other, working together to ensure that resources are protected. All right, now let's have a look at the guiding principles for zero trust. So the first guiding principle is to avoid a binary choice, right? As mentioned, traditionally, implementing network security controls was enough, and it was pretty much what people, organizations, right, implemented. But technology has advanced, and attackers have always found a way to exploit digital assets. Simply implementing firewalls to filter traffic isn't enough anymore, and that has led to most people in the industry saying that the network perimeter is dead. Now, at AWS, we believe that investing in implementing a network perimeter is still important. Most organizations have invested in this area in any case by hiring network specialists. They've trained their teams in this area, and we believe that that investment shouldn't go to waste. Now, as a guiding principle, when you're thinking about security, right, it shouldn't be just about the network perimeter, but it should be about thinking about the identity part, right? Identity-centric controls as well. So this would be in addition to network controls. So you would implement both network and identity-centric controls to meet your security requirements. This approach is something that we have done really well at AWS, and we'll look at some of the examples where we have done this for the AWS Cloud. So looking at this example that you see on the slide, right, we've got an EC2 instance that accesses objects on an S3 bucket. And from an identity-centric control perspective, right, how that works is that EC2 instance makes use of an IAM role. So an IAM role is an AWS concept, and how it works is that the EC2 instance will use AWS credentials to assume that role, and through that role, it will be able to access content inside the S3 bucket. Now, from a network perspective, what we want to do there is we want to make sure that we're protecting that that EC2 instance, right? And what we do for that is we implement security groups. So security groups are basically a virtual firewall, right? So it's a virtual firewall. It's basically a firewall in AWS, right? So it allows you to configure rules, right? Inbound and outbound for your resources within AWS. So looking at identity-centric controls and network-centric controls, you've got an IAM role that has scope permissions. So when the EC2 instance needs to access objects on the S3 bucket, whatever is defined in that role is pretty much what AWS will use to grant permissions. And from a network-centric perspective, whatever rules are defined in the security group, that is what the EC2 instance will be able to do. Now, there is a component on the edge of the VPC there, and that's also another important component, and we will talk about it a bit in the next coming slides. That is what we call a VPC endpoint. And the VPC endpoint is a VPC feature that allows you to connect your VPC resources hosted in a VPC to communicate with AWS services such as S3, such as DynamoDB, such as Amazon API Gateway. So it allows you to connect to those services privately and securely without traversing the public internet. Now, the beautiful thing about the VPC endpoint is that you can attach a policy, right? You can attach an endpoint policy, and this endpoint policy basically ties in together with identity-centric controls, right? In that policy, you can write conditions or rules, right? And filter traffic, right? If anything else inside the VPC that is not defined in the endpoint policy will not be allowed to communicate with the S3 bucket. So just looking at this, right? You have identity-centric controls together with network-centric controls being aware of each other and working together to give you improved security for your applications running on AWS. Right. Now, the second guiding principle is that when you're thinking about zero trust, right, you have to start by looking at the use cases that you're working with. Now, what you see on the slide is some of the common use cases that we find in organizations. You have machine-to-machine, use case where an example here would be microservices talking to each other or talking to an API. Then you've got human-to-application use cases where you've got either a mobile application or web application where humans interact with it to consume some sort of services. So the idea here is, it's important to think about the types of use cases that you're building or that you're working with. Then you work backwards from that, right? You work backwards from the problem, right? This way you'll be able to implement zero trust principles properly within an AWS context. And the last guiding principle is one size doesn't fit all, right? We see this a lot with customers, especially when they're starting out in their cloud journeys, implementing the same controls across their resources. Of course, this can create problems, right? There's applications that are business critical, and there are some that are not. The business critical ones, that's where you would require hardened security, right? While the non-critical ones, security can be, a bit relaxed. Of course, this will depend on your business requirements. But the idea here is that zero trust is a journey, and the starting point should always be identifying the critical points first, then you work backwards from there. All right. Before we move on to some of the examples of zero trust within AWS, just want to check if we have any questions so far. Are there any questions? Okay, no questions. All right. So as mentioned, zero trust is something that at AWS we've done really well, and we've been doing it for quite some time. When we built the AWS platform, we built it, following zero trust principles before zero trust became popular. The first, example for zero trust is really how our customers interact with AWS resources, right? On a day-to-day basis, customers interacting with AWS, services in a safe and secure manner. So the network path, right, to AWS is supported or protected by TLS. Of course, this protects the requests from our customers to the AWS platform. So from a networking perspective, right, we are looking good there. But remember, network controls alone are not enough. in addition to that, AWS requires that every request must be signed with what we call a SigV4 signature. So a SigV4 signature is made up of your AWS credentials, right? These are your access keys and your secret keys. The signing of the request is something that is done for you, depending on what you are using to interact with AWS. If you are using the AWS SDK, the SDK performs the signing for you, so you don't have to worry about that. Now, when the request reaches the AWS cloud, the request is then authenticated and validated before it's processed. So if we think about a use case where you want to upload an object into an S3 bucket, before the object is uploaded to the AWS cloud, what will happen first is that the request will be authenticated and validated before the object is uploaded. And once that happens, once the signature on the request is validated, then the object will be written to S3. Now, the service does the actual validation, right? And the validation of the signature is Amazon IAM. So just looking at this, right, your very simple sort of everyday use case, right, interacting with the AWS cloud, right? You've got network-centric controls, and also you've got identity-centric controls, which provide you with that zero trust framework. Now, let's have a look at another example, right? And in this example, we are going to have a look at how auto-scaling happens on AWS. So it all starts in your account, right, where you are running your EC2 instances. Now, auto-scaling obviously scales, it increases and decreases your compute resources depending on usage. And all this is, triggered by an alarm that you define. And when this alarm is triggered, it then triggers the auto-scaling service, right? And this service runs in a separate AWS account, a production AWS account. The service then needs to talk to the EC2 endpoint, right, to tell it to create more instances in your account. And it needs to do this on your behalf because everything is handled. So what it does is it assumes a role in your account. And using that role, it then requests or makes a request to the EC2 endpoint. Now, what happens is that before the EC2 endpoint can create or provision more compute resources in your account, the EC2 endpoint will then communicate with AWS IAM to validate the signature that is signed to the request. And once that signature is validated, IAM will return a response back to the EC2 endpoint, and from there, the EC2 endpoint will then create those compute resources inside your AWS account. So again, this is one of those things that AWS handles for you, right? Auto-scaling, right? You just specify a configuration, and when an alarm or when that threshold that you define is triggered, this entire process, happens in the background, right? And it's quite interesting actually that such a simple thing that's abstracted away from customers, right? It's something that already implements zero trust principles. All right. I mentioned that we will be talking about some of the AWS services that you can use for achieving zero trust, and that's what we're going to be talking about next. Before we move on, I just want to check again if we don't have any questions. Enoch, are we still good there? We don't have any questions in the queue?
I don't have question. It's clear for me for now.
All right.
Thanks.
All right, so on this slide, we're going to have a look at a 3-tier web application hosted on AWS. So this application is an employee directory app. It allows employees in a company to look up other employees in the same company. So at AWS, our employee directory tool is called phone tool. So let us imagine that we have lifted and shifted this application from on-premise to AWS, right? Now, the application is made up of a load balancer, a bunch of web servers, and a database. Now, the first thing that we want to do is implement network security controls. And for this, we use security groups. As mentioned, security groups act as virtual firewalls in the cloud. Now, with security groups, we can make sure that the web servers can only receive traffic from the application load balancer. And we can also make sure that the database only receives traffic from our web servers. Now, as our infrastructure grows, right, be it through auto scaling or some sort of modernization, right, the same network controls applies, right. As the application, as web servers are being added to our application, the same security groups are applied to our resources. Now, the beautiful thing about security groups is that you can use them to create a boundary, right, between applications. Now, for example, if we were to migrate another application from on-premise, our IT help desk app, right, and we host that in the same subnet as the employee directory app, we can use security groups to make sure that these applications cannot talk to each other, right? Again, Coyote, back to the point that you made, right? Making sure that you don't trust anyone, right? In this particular situation, right, the employee directory app and the IT help desk have no business talking to each other, so we're not exposing that path at all, right? So again, right, these are some of the things that you need to think about, right, when you are implementing zero trust architectures on AWS. So let's start now, modernizing the application, right? So I mean, if we are lifting and shifting an application to AWS, ultimately the idea is that we want to modernize it. We want to create microservices. We want to go serverless. We want to do all the nice stuff, right? Now, we've built new microservices which we want our employee directory app to consume. And these microservices are in different accounts in different VPCs. Now, we know that our employee directory app needs to consume services from these microservices, but how are we going to think about making sure that while doing that, right, we're still maintaining zero trust principles? Now, for that, we're going to use AWS Private Link. Now, AWS Private Link is a service that allows private and secure connection between the AWS VPCs, right? How it works is that when you deploy it, a network interface is created in your VPC, and this network interface allows the application to talk to the microservices in the other VPCs. Again, following zero trust principles, right, we'll secure this interface using security groups. Right? Through security groups, we'll be able to specify which applications can make requests through the interface. Now, obviously, we can also look at identity-centric controls, right, such as mutual TLS and rather OAuth, right, as well, right, to further secure the connection between the two components. Now, as we modernize, right, there's a need to consume services from third-party APIs, things like marketplaces. Again, this is a situation where we can use Private Link again, right, to communicate with third-party accounts to consume services in those accounts.
Sorry, I have a question.
Yeah.
On the previous slide, please. You said that AWS Private Link can connect VPCs. Is it can it connect VPCs across account?
Yes.
Okay.
So that's one of the use cases, right? So think about looking at this architecture, right? Mm-hmm. You've got two microservices, right? And those microservices are fronted by API gateway, right? Sometimes other customers won't use API gateway, right? They will use other services, or maybe EC2, right? So it pretty much establishes a connection, right, between one VPC in one account, right, to another VPC in a different account. So that connection is established using the AWS backbone network. So you never get traffic traversing the internet. So those VPCs are connected privately and securely on the AWS network.
Okay. Thanks.
All right, cool. Right, so moving right along, we're still modernizing our application, and our next step is to relook at replacing our relational database with a NoSQL database, right? And for that, what we're going to be using there is DynamoDB, right? Now, because DynamoDB sits in a public domain of the AWS cloud, so what we want to do there is, well, we've got two options, right? For our employee directory app to communicate with DynamoDB, it can either traverse the internet, or we can use some sort of private connection, right? And for that, we're going to be using a VPC endpoint. So with the VPC endpoint, how it works is that you attach it to your VPC, right? And all the traffic that is meant to be going to DynamoDB, you will route that traffic via that VPC endpoint. Now, in a couple of slides ago, I mentioned when we were looking at identity-centric and network-centric controls, we looked at this scenario where the EC2 instance wanted to access objects on an S3 bucket just using IAM, right? And this is exactly the same, right? You've got our web directory app, particularly the web servers, accessing data from the DynamoDB table using an IAM role, right? And in order to assume that role, they need those credentials, right? And obviously those credentials are then used to sign the requests as they are sent through to DynamoDB. Additionally, with the VPC endpoint, you've got a policy that you can implement to lock down traffic, right? That policy in this particular case, we are only accepting traffic from our security group that is protecting our the web service for our employee directory application. All right, and again, right, we are continuing to expose microservices to our application. Again, right, this is another scenario, another situation where we can create another VPC endpoint and connect that VPC endpoint with microservices in a different account, right? Now, I probably know what you're thinking right now, right? What is the difference between VPC endpoint and private link? So, as mentioned, the private link allows you to create a private connection, right, between VPCs, right? A VPC endpoint pretty much does that, right? But specifically for AWS services, right?
Yeah.
So these services can be, services such as S3, as we saw in the previous example. It could be services such as DynamoDB. It can be services such as Amazon API Gateway, right? Now, much like a private link, right? It allows you also to create that connection, that private connection with these services in different, AWS accounts. So that's pretty much how it works. I think the key thing, right, to remember is that with private link, right, it creates the connection between VPCs, in different regions and different accounts, right? But with a VPC endpoint, right, it's specific to a particular AWS service. So as mentioned, it connects your VPC with a specific AWS service such as API Gateway, DynamoDB, or S3. So that's the key things to remember there.
Okay, thanks.
All right. Again, right. Our help desk application doesn't need to communicate with our microservices, right? So we're not exposing a path there either. All right, so as we continue to modernize, right, adding more microservices and other components, we'll pretty much end up with something like this. Now, as you can see, we have multiple microservices talking to each other across multiple VPCs and accounts. Now, implementing zero trust can be a challenge, right? As we saw, right, there's a couple of things that you have to look into, right? If you're using, VPC endpoints, you apply a policy there. We saw that, you can even have a VPC, you have to have a VPC endpoint for each endpoint that you're using, right? So that means that multiple endpoints, multiple policies, multiple rules in the security groups, things like that, right? It can get, complicated, very quickly. Now, as mentioned at AWS, we, talk to our customers a lot, and we're always, looking for opportunities to innovate on behalf of our customers. And, we're always thinking about how we can make life easier for our customers. And that is how Amazon VPC Lattice was born. So VPC Lattice is a service that makes it easy to connect services across VPCs and accounts. So it allows you to centrally manage access and communication between multiple services. It's built in such a way that anybody can connect services, right? You do not need to be a network administrator. So it allows you to have, apply the granular access controls in order to achieve zero trust. Now, as we saw in the previous slides, right, as components, services are added to the application, it can get difficult applying those granular controls. VPC Lattice helps with that. So let's have a look at how it works, right? So let's imagine that we've now added more microservices, right? So we've got a location microservice, we've got a direct reports microservice, and we've got an awards microservice, right? And of course, we've got our employee directory application, right? We know that this application needs to consume from these services, right? Now, how Amazon VPC helps with this is that there is a concept called a target group, right? So a target group is nothing similar. It's actually similar to application load balancer target groups, right? It's basically a collection of resources that you want to have, pointed to, right, by a particular service, right? So we pretty much implement the same thing. So VPC Lattice pretty much acts as a proxy, right? So it will be redirecting traffic to these target groups that we have configured. Now, the next thing that we want to do is we want to create services, right? A service is, again, excuse me. A service, again, is a VPC Lattice concept, right? It pretty much points to the actual target group, right? So in the service, you can pretty much write rules on how to, redirect traffic, right? So yeah, we're gonna add the service for the awards VPC or microservice, and we're also gonna add an org chart service, right? For the two microservices, which is the location VPC and the direct reports VPC. And of course, those services to communicate with the microservices uses a AWS Certificate Manager certificate. All right, and then we have what we call a Lattice service network, right? So this is pretty much the actual service where all the traffic, right, will be redirected to, right? So from our employee directory application, as we are wanting to consume those different microservices, what's going to happen is that traffic will be redirected to the VPC Lattice service network. Then from there, the traffic will be distributed across the different microservices through the services that we've created. But before that can happen, we have to associate the services, the award service and the org chart service with the VPC Lattice network. And of course, we have to make sure that our employee directory app is also associated with that service. And once that happens, then we can now then have traffic flow through to microservices using VPC lattice. So VPC lattice obviously is a way of the services that we've created, and the rules within those services will then be used to evaluate how to handle the traffic. So on a high level, right? On a high level, this is pretty much how VPC lattice works, right? Makes it a whole lot easier to handle different network flows that you might have in your application. I, for one, love this service because I am not a networking person. If there are networking people here, I'm sure you can also appreciate a service like this, right, where you don't necessarily have to worry too much about remembering the IP ranges of all the components, because you will need that, right, when you want to whitelist those applications and making sure that you're opening up the right paths, right, for communication, right? Do we have any networking people in the house today? Any network engineers?
Me, not engineer. I just have a degree in network.
Ah, nice. So yeah, I think you will love this, right? It makes life simple, right? And like I said, right, I consider myself a lazy developer, right? So any opportunity to try and do something in a very easy way, in a straightforward way, I will definitely explore that. Do we have any developers today?
Yeah, I'm a developer.
Okay, cool. So Emmanuel, I'm assuming obviously the age that we live in, right? Modern developers have to wear like quite a few hats, right? You have to do a little bit of sysadmin, infrastructure deployment, some networking and security, right? So I think it's important as a modern developer to be able to do that kind of stuff, right? This is something definitely I think will save a lot of time for you, right? So yeah.
Yes, right.
Okay, cool. Before we move on to the next slide, everybody, I just want to pause there and make sure that we are still on the same page, that you're still with me. I'm not talking too fast, and also see if we don't have any questions.
I have a question.
Mm-hmm.
So if I missed that, if you said that, but with the services that we created, can we manage also the outbound traffic, maybe from EKS to the app side?
So you are referring to the microservices, right? So
Yeah.
the location VPC, right? You're asking if you can manage the outbound traffic. So the
Yeah.
outbound traffic, that would be going back to the VPC lattice service network? Is that what you're asking?
Yes, I want to know if VPC lattice will can manage the outbound traffic. If with that we can restrict access to some internet service.
So so with VPC lattice, right? I think the important thing to understand is it acts as a proxy, right? So if you're wanting to access these different microservices, right, you're going to have to go through VPC lattice, right, before you get to the services, right? But the services themselves, right, you still pretty much implement the standard basic networking principles, right, from an AWS sense, right? So if you ever look at the location VPC, right, that EKS cluster is sitting inside a private subnet, right? So it being private, it means that it can't, traverse the internet. Do you get what I mean? If you did want that to happen, then you would have to, look at different ways that you could do that, right? Have a public subnet and have some sort of, net gateway that will help you with that, right? But as far as this architecture is concerned, right, these services are meant to be private, and they will not be able to, obviously, traverse the internet or make any outbound requests unless if we allow that.
Okay, okay.
Does that make sense, Enoch? Does that answer your question?
Yes, yes, yes. Thanks. I missed that the VPC, the subnet was private.
Yeah. Okay. No worries. Yeah, and I think with this architecture, right? It's not quite done, right? There's still a couple of things, right? So obviously, right? Because VPC Lattice has come in and made life simple and easy for us in terms of managing the traffic, and exposing, the different, many microservices that we have. We still need to think about, implementing those network, controls, right? And again, our security groups become, very, very important again, right? Implement security groups for our employee directory application. We also implement security groups for all the different microservices that we have. And again, identity-centric controls, right? This is where IAM, right? IAM roles, come into play, right? This is where having those AWS secret key and access key, become important. Those are then used to sign the, the request as the traffic flows through the different components, right? So simply because this is within an AWS network, right? We don't assume that things are secure, right? We still ensure that traffic within that AWS environment is still using some sort of an identity-centric control, and having that SIG-v4 signature sign the requests for every component, right? Is still important. It's still important in us achieving that those zero trust principles. Right. So that was looking at obviously machine-to-machine communication, right? As mentioned, machine-to-machine communication is one of the common use cases and probably one of the most important ones, and also easier, right, to handle, right? And now what I want us to do is zoom out a little bit, right? So let's think about how humans are going to be interacting with the application, right? And John, let's think about how does zero trust come into play, right, for a use case like that. So we're looking at the human to application use case, and in this use case, the goal is to improve mobility and user experience, right? We want to make sure the application is available anywhere while we maintain our high security standards. So let's have a look at how traditionally, right, this application will be accessed, right? And I use the word traditionally loosely because this is a pattern that is still widely used today, right, by many organizations, right? So you have your employee directory application sitting on AWS, right? And if you need to access that application, generally what would happen is that you'll be sitting in the office, right? And how you connect to AWS, right, is they connect using VPN, or you use Direct Connect, right? So VPN is just simply that, right? It's an AWS VPN service that allows for VPN establishment between your on-premise office to the AWS cloud. Then, of course, you've got AWS Direct Connect, which is a dedicated line, and its use case is pretty much for improved bandwidth. Bandwidth, uninterrupted bandwidth. Now, what about for, we live in an age where people, can work remotely, right? So you're working from home, but you need access to this application. So how does that look like, right? You would have to, VPN in, right, into your on-premise VPN service, right? And from there, then using your VPN client on your machine, then you are able to connect to the AWS employee directory app, right? So that is one of the patterns that we still see, right, today, right? As mentioned, it works, right, for organizations, right? And I still even use this pattern even today, right? But as mentioned, at AWS, we're always looking for ways to innovate. We're always looking for ways to improve things for our customers. Now let's have a look at another one, right? So this is a more granular one, right? Here, our employee directory app is deployed in a public subnet and in a private subnet, right? This is, again, right, the common pattern. You have AWS WAF, which is web application firewall. This is one of the security services that protects against sort of layer 7 attacks, right? So if we are thinking about cross-site scripting attacks, right? This is a service that you would use at the perimeter, right, or the boundary of your network to make sure that such attacks don't make it through to your resources. And another service that can be used at the perimeter of your network, again, is AWS Shield. AWS Shield is a service that can be used for things like detection and handling of DDoS attacks, right? That is something that you would implement specifically for that. So as a remote user, right, you'll be going through the internet to access the employee directory app, right? But obviously, before you can do that, there must be some sort of authentication, right? And the good thing with application load balancer is that you can have an integration with OpenID Connect. So OpenID Connect basically is a standard, right, that that streamlines authentication for web application services and things like that, right? So you would first start by authenticating with your identity provider sitting in your corporate ID, right? And once authentication is successful, then you're able to access the employee directory application. So another pattern, right? Again, it's the pattern that we still see even today. Most organizations use it. It depends on the security requirements of each organization. Now, as mentioned at AWS, we're always looking to innovate on behalf of our customers. We're always looking to try and make life a little bit better and simple for our customers. And we pretty much looked at ways on how to improve, that access for our customers, right? So that human to application use case, right? How do we make sure that our customers build solutions that don't require the users to be using VPN connections that might not be stable, using VPN agents and things like that, right? Just providing a very simple user experience for them to be able to access their resources, right, while maintaining the high security standards. So this is where Amazon Verified Access comes into play. It's one of the services that was announced last year at reInvent, and it went generally available this year. So let's have a look at how it works. So we still have our employee directory application, and this time, right, we can actually host it on a private subnet because that's best practice, right? But the only difference here is that we've got verified access, right? Now, as a remote user, you can access that application through verified access. So you can access that that application through verified access while it's still sitting in a private subnet, right? But again, right, there has to be some sort of controls, right, that you put into place, right, to let your users authenticate, right? And that's where your corporate identity provider comes in, right? You still authenticate with your corporate identity provider. You get your tokens or your whatever it is that whatever protocol that it supports. Then through that, you're able to access that application using verified access. Another feature that verified access has is device posture management, right? So context is very important when it comes to detecting anomalies and security events, right? So what happens here is that verified access is able to get your device footprint and other device signals, right? And if it detects that there's some sort of suspicious behaviors coming through from a particular request, then it's able to take action against that or block the request altogether. And yeah, right. So and that's what you want, right? You want to be able to use a service that can use other signals, right, to detect if there's any anomalies, right? If an attacker comes, so for example, an attacker is able to get a hold of your your ID token, right? And they're able to make a request to verified access, right? Well, if they're able to get your ID token, right, they'll still need your AWS credentials, because again, they'll still need to be CB4 signatures being passed to verified access, right? So again, right, they'll need to get your AWS credentials and also get your ID token somehow, right? Let's say they do get that, right? Verified access is able to have a look at the location where the person is coming from and the device that they're coming from, and use those as signals, right, to make sure that there aren't any anomalies before it allows access into the application. So that's one of the services that we launched, and these services are geared towards simplifying user experience for users wanting to access corporate internal applications. Like I said, traditionally you use VPNs and things like that, but verified access is there to simplify that entire experience. Now, another thing I wanted to talk about, and this is the last topic or the last sort of section I wanted to cover today, right? Is authorization, right, inside applications, right? So most of the most customers that we talk to, right, and I think it goes for most developers, right, when you are building an application, right, security is important, right, authentication is important, authorization is important, right. Of course, there's frameworks such as OpenID Connect and Auth2 and SAML, and those frameworks, they make life easier in terms of standardizing how authorization or authentication should work, right. But the challenge with that is that most developers have to, bake in the logic, right, for authentication, right, and authorization, right, into the application, right. Now, if you ever look at where the industry is right now, when it comes to authentication, that has now been offloaded, right, to services or products, right, that deal with that, right. So from an AWS perspective, we have Amazon Cognito, Ping Identity has their own, SaaS product for that. Azure has their own, Auth0, Okta. So all those products, right, they were pretty much looking at, decoupling, authentication from applications, right? And but there's still a part that remained with, with application, and that was authorization. And that is, one of the things that, we've picked up from customers, that they would like a way to decouple that, right? I mean, if you have a look at where we are right now, right, modern applications, we build microservices, we build serverless, applications, and these modern applications are very, decoupled, right? And to solve that problem, where authorization still happens at app level, we launched a service called Amazon Verified Permissions. Now, if you look back at the employee directory app, with each component talking to each other, performing authorization for a request, means each microservice will have to include some sort of logic to determine if the request is, authorized or not, right? And, customers want to move away from this, right? Modern apps are highly decoupled, and there's a need to, decouple that authorization part as well. And that is where Amazon Verified Permissions come in. So it's a service that you can use to perform, that authorization part, right? It's built on a policy engine called the CEDAR policy language. It's a policy language that we've built specifically for this service. We also have open sourced it to allow collaboration from our partners and customers. So what you see in the slide is an example of how it works. It uses both role-based access control as well as attribute-based access control. So this is how it works. So if you take a simple use case of an employee updating a customer record on a database, so instead of the application doing the heavy lifting and checking if the the employee is authorized, and typically how this would happen is that you would have an ID token of some sort if you are using Auth2 or OpenID Connect, right? You would have an ID token, an access token, and a refresh token, right? And obviously the ID token contains the information about the identity of the user, and then the access token is information about what the user can access, right? So that's what you would use for authorization. So typically, right, you would inspect the token in your application, or you would build some sort of service, right, that does that for you, right? So, and when a user tries to do something, then that access token, and including the ID token as well, is sent to that service. And in that service, you build logic to validate, the tokens, and do all the other logic that you need to do to determine if this particular user can be allowed to do what they're trying to do. Again, right, that's be it you writing that logic on the application itself, or you have a service that does that. It's effort that you have to put in, right, to make sure that you're writing proper authorization logic for your application. Looking at this particular situation, all you have to do with Amazon Verified Permissions is that you define your policies, right? You define what needs to happen, right, for particular users, right? You define those attributes that users need to have in order to access, certain things, right? So in this particular situation, an employee wants to update the database, the application, before it allows that to happen. It then makes the request to Amazon Verified Permissions just to check if this person is allowed to do that. And if the decision is that, okay, cool, this person is allowed, depending on the rules, depending on the attributes that you've set, then a response is sent back to the application, and the application allows that employee to update the database. So that's how it works. Before we talk about this slide, I want to pause there. I've spoken about verified permissions, and I've also spoken about verified access. Do we have any questions on those two services?
Not for me.
All right, anyone else? Are we still good? Still on the same page? I haven't lost you yet. As they say, silence is good news. Okay, cool. So now putting everything together, right? This is what we have. This is probably not the best architecture diagrams because there's a lot happening here. Apologies for that. But on the human to machine side of things, right? We have verified access, making it easy for humans to interact with our application in a secure manner, with network and identity controls applied. On the machine to machine side of things, we have VPC lattice simplifying communication between the different components that we have in our application. And we also have security groups, endpoint policies, verified permissions, making sure both networking and identity controls are applied. So all these things, right, they enable us to achieve zero trust principles on AWS. And as mentioned, right, it's important, right, to work backwards from your use case, from your problem, right? Security, or rather, just security as a whole, right? It's a journey, right? You start from somewhere and you have an end goal, right? And the best way to start, right, as we always advise our customers, is to start from the problem, right? And you work backwards from that. We've seen how that can, be done for machine-to-machine use cases. As mentioned, these are, usually your, most critical, but at the same time, the easiest ones to start with, right? You start from there, right? You have a look at what you can do, right, to start thinking about implementing those principles, right? As you've seen, there's quite a few AWS services that can be used, and this session, right, I've only covered just a few, right, but we have other AWS services as well, right? And which service you use, that depends on your use case. Again, with the second use case, we looked at how to apply those zero trust principles for humans accessing your application, looking at verified access, doing away with VPN clients, having to deal with multiple hops before you can just access an internal app, right? So vastly improving that user experience, but at the same time maintaining those identity centric controls and network controls as well. So again, right, it's important to start from from your use case. You identify what the use case is, and you work backwards from that. And that's that's the advice that we give to customers. And I only covered these two use cases because these are the most common ones. There's many more, right? And those will also require different AWS services. But for the purpose of today's talk, just to show you how zero trust principles can be implemented in AWS, we're just looking at these two use cases. And with that, I've come to the end of my session. Thank you for lending me your ears. I hope that you've enjoyed the session. And Njara, I would greatly appreciate it if you could, provide feedback. As mentioned at AWS, we are very customer, focused, and we would like to, improve on our offerings. And the same goes for the sessions that we have with our communities. Would like to get some feedback from you. Scan the QR code, and it will take you to a link where you can provide some feedback. Before I hand over to Enoch, I think we still have some time, right? If we do have any questions, I think now is the time to, to chat a bit more about some of the stuff that we touched on.
Okay, so I have a question. Can I go on?
Yeah, go on.
Okay. Okay, most of the things you spoke about were very technical and tool specific. So generally, when you are introducing an organization to zero trust policies, what potential challenges or what pitfalls do you also make them aware of while transitioning or while using the zero trust?
Okay, cool, Cody. So, as mentioned, right, security is, is a journey, right? And I think the experience that I've seen, right, working with, with customers, in South Africa and across the EMEA, right, it's not just about, security, right, but I think that the journey starts from, when you adopt AWS, right? And usually, right, the change in how things are done, right? So that's usually the first stumbling block, right? The people, right? How you see security, right, on premise versus how you see security on the cloud, right? If you ever look at some of the stuff that you spoke about, right, is stuff that already exists, right? Industry-wide, a concept of a firewall, right? Is stuff that is has been around for quite some time, right? But how you think about that, right, in the cloud is very different, right? And so yeah, just the shift in your mindset, right, in terms of how you think about cloud security, right, as a whole, right? That's usually the one of the stumbling blocks, or one of the things that can derail things, right? So one of my customers, right, for example, right, I am not able to have a proper conversation around the different security methods that they can implement properly, because, for example, one of the things that should be like first step, right, when you are moving to cloud, right, is setting up what we call a landing zone, right? So a landing zone is a structure of it's a bunch of accounts, right, where we pretty much help you to structure them in such a way that you're following proper security and governance controls, right? If that is not set up properly, right, it's very difficult to have conversation about some of these frameworks, because that's really the foundation, right, that you need to set before you can now start thinking about, okay, cool, let's have a look at how to implement zero trust. I mean, there's nothing stopping them from implementing zero trust, even with whatever account structure that they have, right? But again, right, it's the whole thing of you don't have the right things, right? You don't have the right foundation, and whatever it is that you implement now, right, might not whether you like it or not, right, might not, follow best practices, might not be a proper zero trust architecture, right? I hope that answers your question.
Yes, it does. It does. So we have to take proper care of the people who are going to the people at the main point of contact first before moving on with whatever it is we want to do.
Exactly, right. It starts with the cloud, right? The minute you migrate things to or the minute you make a decision that I'm going to migrate to AWS, right, or to the cloud, right? That's where it starts, right? There's those fundamental building blocks that have to be put in place, and for those things to be put in place, right, it can be challenging because of people have to change their mindset. One of the things I mentioned, when I was talking about how we see zero trust, is that we understand that most organizations have invested heavily, right, in implementing proper network controls, right? And these network controls are essentially network controls for on-premise, right? Because typically that's where most organizations are running, right? Those network controls are still very, very, very valuable, right, for that organization, right? Those people, those network engineers, with all that knowledge and expertise, it's still very, very valuable, right? But the challenge is getting them to think differently about the cloud, right? Getting them to think differently about a simple concept such as a firewall, right? So it's things like that. And once we see, right, that change, right, and organizations, and the different teams, right, start to change their thinking about the different concepts, right, then it gets easier for them to start moving at a much faster pace, right? But of course, at the same time, right, implementing best practices when it comes to security.
Okay, thank you very much.
Right, thank you, Coyote. Any more questions, everybody? Emmanuel, you've been quiet. Do you have any questions?
No, I have no question.
Right, Lionel, how about you? Sorry for putting you guys in the spot. If you don't have any questions, that's fine. I really enjoyed spending the last couple of minutes with you. I do hope that you have learned something from this. And and I do hope that this is something that that sparks conversations, right, around security. So yeah, Enoch, I think over to you.
Okay, thanks, Elton, thanks everyone. This session was very insightful. Somebody can help me to do the recap in French. Oh, okay. Bouclet, you want a recap of all the meeting? Bouclet, vous me recevez? Vous voulez un meeting? Vous voulez un recap de tout ce qu'on a dit aujourd'hui?
Ce ne sera pas de refus pour moi. Hein.
Non, c'est pas trop, c'est juste un résumé pour mieux comprendre. Bon, j'ai écouté, mais mon anglais, moi j'écoute anglais, mais pas bon niveau de l'anglais. Donc, j'ai essayé de comprendre quand même la part de la sécurité, mais si vous pouvez juste faire un résumé pour qu'on puisse comprendre l'utilité.
Okay, je vois. Elton, we have a booklet that want a recap of what we said today, but in French, because I think he missed a lot of information. But maybe we can make a follow up in French. Maybe we can make some hands-on session to help people to get more information on that?
Yeah, I mean that's something that we can have a look at, right? So just on that point, right? We do have AWS solutions architects, right? That obviously speak French, right? And we can definitely make sure that for next sessions, right, we can have somebody who speaks French, right, to come through to the sessions, right? So it's definitely something that we can do. For this particular session, I'm just trying to think, right, what would be the best way, right? I think just thinking, right, there is I mean, you could use one of the AWS services, right, to translate, the audio into French, right?
Okay.
That's an option. So yeah. But definitely, in terms of follow up, in terms of the next sessions, right? We can definitely look at having an AWS solutions architect who speaks French.
Yeah.
Yeah.
Maybe I can do some recap right now for Beauclair. Beauclair, en fait, ce qu'on peut retenir en majeure partie, c'est que le Zero Trust nous permet de suivre des règles pour implémenter. Bon, le Zero Trust, c'est comme un ensemble de règles, d'accord? Un ensemble de règles pour sécuriser notre infrastructure sur AWS. Donc, on a par exemple plusieurs cas d'usage lorsque on a des communications à sécuriser d'une machine vers une autre machine. Donc, c'était le use case qu'on appelait machine to machine. Et dans ces cas-là, il fallait par exemple utiliser des security groups pour dire que telle machine est autorisée à parler avec telle machine uniquement. On a aussi le cas où on utilise où la communication se fait entre un humain et une machine, donc human to machine. Et dans ces cas-là, un instant, je scroll sur le slide. Et dans ces cas-là, en fait, on peut retenir le service AWS Verified Access et le service AWS Verified Permissions. Donc, voilà un peu en majeure partie ce qu'on peut retenir aujourd'hui sur tout ça. Aussi, il y a le service AWS VPC Lattice qui nous permet en fait de gérer les flux réseau entre plusieurs VPC, qu'ils soient de même compte ou pas. Il nous permet de gérer les flux réseau de plusieurs VPC. Et en fait, ce qui est bien avec VPC Lattice, c'est que lorsqu'on commence à implémenter des network rules pour spécifier quel VPC peut communiquer avec un autre, on peut se retrouver avec beaucoup de règles et on a du mal à suivre l'historique des modifications. Mais avec VPC Lattice, en fait, on a un panel unique dédié qui nous permet de gérer toutes les règles network dans notre infrastructure. Je pense que c'était un peu clair quand même. Ou plutôt, j'espère que c'est assez clair comme ça.
Oui, merci beaucoup.
Je vous en
Ça me
prie.
rassure plus.
Et aussi, je pense on pourra faire plus tard dans l'année une session, ce qu'on appelle un follow-up pour faire des exercices, d'accord, hands-on sur cette technologie-là, toucher ça du doigt et faire des labs, voir comment ça marche en pratique.
Merci beaucoup. Merci à tout le monde.
Je vous en prie. So, Elton, I think I don't lie too much. I just thought that we will make a follow-up, maybe hands-on session to touch services like VPC Lattice, AWS verified and verified access, and I don't remember the name of the second, and verified permissions.
Yeah. Okay, cool. That's not a problem. And I was also thinking, if you would like, I'm more than happy to see if I can. So you recorded this session, right?
Yes.
Yeah. So if you can send it to me, I can see if I can run it through Translate, and we could probably have some translation as well, and I can send it back to everybody so that they can watch it again in French.
Okay. 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 So I will contact you for that.
Yeah. Yeah. Just send me the video, and then I'll see what I can do. Yeah, I'll just use Translate, AWS Translate to translate to French. Then yeah, I'll send it back.
That will be great. Thanks. So shall we call it a day?
Yes. If there aren't any more questions, yes, I think we can call it a day.
Ok. J'espère que vous n'avez pas d'autres questions. Ok.
Non, ça va pour moi. En tout cas, j'ai aussi profité du ReCap. Ça m'a permis d'une certaine manière de consolider ce que j'ai appris aujourd'hui. De toute façon, j'ai appris de nouvelles choses aujourd'hui.
Okay. Elton Emmanuel just said that he learned something new today.
Yep.
So I think that's all for today. Thanks, everyone.
All right. Thank you, everybody, for making the time. Really appreciate you coming out on a Saturday and spending the hour with me. Thank you, and Damija, and I hope that I get invited back again soon.
Yes, thank you, Elton.
Right. Goodbye, everybody. Enjoy your Saturday.
Thanks. Bye-bye.
Goodbye. Thank you.
Okay, goodbye.
Thank you. Goodbye.